An early zoogeographer is this scientist named Wallace, who divided the globe into these 6 biogeographic regions. And I just want to mention him. I don't think it's terribly important, but I want to mention him in case you ever hear about him. So the idea here was that you could make these longitudinal bands across the globe, and those bands that are closer to the equator have more biodiversity than those that are further away. And by and large, this rule makes sense. So if we think about all these concepts, the effect of latitude, the effect of latitude on diversity of mammals is one of the reasons we have more animals in that Ethiopian or Afrotropical region, the Neotropical region, and the Oriental or Malaysian region. These are areas that are tropical, they're near the equator, versus the Palearctic, Nearctic, and Australian areas, because those are temperate or Arctic regions that are further away from the equator. When we looked at those zoogeographic regions, one thing that I pointed out was the differences in the number or proportion of endemic species. Endemic species are those species that are found only in that area. And this is often an artifact of the different corridors that exist there. So if you look at the Palearctic and the Neoarctic regions, this would be like Asia and North America, there are few endemic species here because there are few barriers to dispersal. So many of the same animals you have in the Palearctic show up in the African region or show up in the Oriental region. And similarly, what we have here in the Neoarctic, many of those species or most of those species show up at some level in South America as well, because there are intact corridors that have allowed animals to move back and forth between these regions. And that's in contrast to the Ethiopian region, also called the Afrotropical, the Neotropical and Australian regions. These are areas that have a lot of endemics because they were separated by filter routes. And recall, a filter route are these routes that some animals can cross, but not all animals. So corridors are fairly easy for most animals to pass. Filter routes are corridors only some animals can pass through, like the Bering Strait. Small animals would have had a hard time crossing the Bering Strait, whereas large things like camels and horses didn't have much difficulty with that. Then the last one would be the sweepstakes routes, which are those kind of really, just animals that got very lucky and got on a raft or something, were able to float from one area to another area. If we look at the Ethiopian, the Neotropical, and Australian regions, these have large numbers of endemics because they're separated by filter routes. And the Neotropical, we had the Panama Land Bridge. Right now, there's a land bridge that goes through Panama and up through Nicaragua and Costa Rica. But during the warmer periods, that area was inundated with water and animals weren't able to cross through there. So these filter routes that sort of limited the type of animals that can cross through there is one of the reasons we have more endemic species in these areas. The Ethiopian region compared to the Palearctic, you have the Sahara Desert, which acts as a big filter route. So some large animals can make it across the Sahara Desert, but some of the small animals are going to have a really difficult time. And then there are the sweepstakes routes also that have limited some species from moving into those areas or out of those areas. The oceans are a huge barrier that act as a sweepstakes route. So Australia, there's an ocean that separates Australia from other areas. So the animals that got there either went through a land bridge that existed during one of the ice ages, or they got there through these sweepstake routes where they just kind of floated over there and were lucky and were able to float to those areas. So the number of endemics is going to be a reflection of the type of corridors, how intact those corridors were, and how far away these regions are from each other. The effects of island biogeography can be seen across similar latitudes. So if you looked at the Nearctic, which is North America, versus the Palearctic, which is Europe and Northern Asia, these are areas that are similar latitudes, but the Palearctic zooregion is larger, and therefore it has more families than a smaller one with a similar latitude, the Nearctic. This is true also for the Ethiopian or Afrotropical landmass. It's at approximately the same latitude as the Oriental landmass, but it's a larger landmass, and there's more families there because of that. The small distant islands have fewer species than the large near islands as well. So we can see similar trends based on how far away these are from each other also. Within a zoogeographic region, species diversity is not homogeneous. So at lower latitudes, we have higher species diversity. If we look at the Nearctic in North America, the southern areas have more diversity than the northern areas. So it decreases as we go towards the poles. And then again, just reiterating this, at any given latitude, the more topographic relief you have, the higher biodiversity you have as well. So this is that map that you've seen, a few different versions of that. We can see that this is the Neotropical region. The closer to the equator, we have higher number of mammal species, and the closer we get to the poles, the lower number of species we have. And then even within the same latitude, those areas that have a lot of topographic relief, like the Rocky Mountains, the Sierras, those have a lot more biodiversity than, say, we have here in the Ozarks. So that's all we're going to talk about in terms of zoogeography. This is an image of monkeys or chimpanzees. Chimpanzees do not swim very well, so chimps are actually limited by water, and water serves as a filter route for them. So that's a good illustration to leave with. I think for today, for Wednesday, I'm just going to go ahead and stop here. On Friday, we'll start talking about chapter 12, which are those elephants and hyraxes and the manatees, and we'll pick up at that point. So those of you that like to read ahead, feel free to. We'll be in chapter 12. We're skipping over chapter 11. We're jumping straight to chapter 12 with orders Proboscidea, Hydrocidea, and Ceridia. These are the elephants, the hyraxes, and the manatees. And like I said, I think these are important to talk about just because they're animals that people are very familiar with. All right, I'll see you on Friday. Not sure if I'll be in class or if we'll meet again like this. All right, thank you. Bye-bye.